Section 9.2. Today we're going to look at parabolas. Parabolas are the graphs of quadratic equations. So remember, a quadratic equation is one that looks like this: y equals x squared minus 6x plus 7. Remember, this has an x squared, so this is not a linear equation, so our graphs are definitely not going to be lines. Our graphs are going to be something called parabolas. Parabolas have this basic shape. Okay? Sometimes they'll go the other way, sometimes they'll be down, and we'll see an example of that here. But they have this basic shape. When you're dealing with a parabola, the single most important point on a parabola is called the vertex. And the vertex of a parabola is either the lowest point, like in this case, or if the parabola were to go the other way, if it were to be opening down, the vertex would be the highest point. And we'll see an example of that here as we go. What we notice about a parabola is there's a symmetry property. What I mean by that is if I could draw a line right here, and if I could fold the paper right on that vertical line going right through the vertex, this part would fold over and perfectly lay right on top of this part. And that's called symmetric. So we would call that symmetric about this vertical line. So here's how this is going to help us. The first thing we're going to want to do to graph a parabola is find the vertex. So notice I've given you 2 points here. I've given you the point 0, 9, and I've given you the point 10, 9. Notice they have the same y value. Both have 9. So if you can find 2 points that have the same y value, given the x numbers, the vertex has to be halfway in between, right in the middle. Because if I fold this over, the distance from here to here has to be the same as the distance from there to there for that point to fold over and fall right on top. So the first problem asks, find the x-coordinate of the vertex. The x-coordinate of the vertex would have to be x equals 5. It would have to be halfway between 0 and 10. Halfway between 0 and 10 is 5. Okay, question number 2 says, find the x-coordinate of the vertex of a parabola that passes through the points 0, -3 and -7, -3. Round appropriate answers to the second decimal place if needed. Alright, well, I'm going to draw us a little picture here. I'm going to draw it up here where I have a little room. It says we have a parabola, and it's got 2 points. It's got 0, -3, which might be right here, and it has -7, -3, which might be right here. Now, it doesn't tell me if this parabola is going this way or if the parabola is going that way. And the truth is, it really doesn't matter. So just for fun, for this one, I'm going to pretend that our parabola is going this way. For the purposes of this problem, it doesn't matter which way it's going. What they want to know is find the x-coordinate of the vertex. And again, the point is, we have 2 points that have exactly the same y value. They both have exactly y equals -3. I look at the x numbers. The vertex would once again have to be halfway in between. So what's halfway between 0 and -7? To find halfway in between two things, you add them together. You take -7 plus 0, and you divide by 2. So that's -7 over 2, which means the x-coordinate of this vertex is -7 over 2, which I suppose you could write as -3.5 if you wanted to. Although truthfully, I'd prefer you just leave it as a fraction, -7 over 2. Okay, I hope that's clear so far. Number 3, a parabola has the vertex 2, 5, and the y-intercept 0, 9. Find another point. Alright, once again, I'm going to draw myself a picture here. My vertex is 2, 5. 2, 5. Another point is 0, 9. So this is the vertex, which means it's either got to be the high point or the low point. Well, from this graph, it's got to be the low point because this one's higher. So my parabola has to look like this. find another point on the parabola. Here's what I'm going to do. I'm going to come straight across. If I come straight across, my y value has to be 9 still. What does the x value have to be? Well, let's see. The distance from going to here to the middle would be 2. So the distance going from here to this point would also have to be 2. Again, that's the symmetry property of parabolas. If I were to draw this vertical line, and I could cut it and fold it over, these would have to match up. So since this distance is 2, that distance has to be 2. 2 plus 2 is 4. So that point would be the point 4, 9. So you might notice a pattern here. The pattern you might notice is on these parabolas, we're always dealing with 2 points. We're starting off with 2 points here. One of these points is always the y-intercept. And then we find this other point, and then our vertex is going to be halfway in between. Okay, so that's going to be huge for number 4 here. Number 4 says, graph the given functions by hand. Find the vertex. Here's what we're going to do. We're going to build ourselves a little table. We're going to find the y-intercept. Finding the y-intercept is one of our favorite things in the world to do because it's usually very, very easy. We plug 0 in for x. When we plug 0 in for x, we get 0 minus 0 plus 7. That's 7. So far, I know I have 0, 7. That's right there. Now, what has to happen is this parabola might go down and come back up, or it might go up and come back down, but somewhere there has to be another spot where this hits a y value of 7. So I'm going to take 7 and actually plug it in as a y number. That's a very unusual thing to do. We almost always plug in numbers for x and figure out the y's. Here we're doing something unusual. I'm going to plug 7 in for y, and we're going to find the x. So I plug 7 in for y. I get 7 equals x squared minus 6x plus 7. And I'm going to solve this equation. To solve, I subtract 7 on both sides. 0 equals x squared minus 6x. Alright, well notice what we have here. We have ourselves a quadratic equation. And we spent quite a lot of time recently learning how to solve quadratic equations, and this is why we learned how to do it. To solve this quadratic equation, I notice I can factor. I can factor an x out as a greatest common factor. So now I take the x equal to 0. Notice I already had that one. X equals 0. There it is. And then I take x minus 6 equals 0. I solve. That one gives me x equals 6. So that allows me to fill in my chart. Now I graph the point 6, 7. That's right there. And now my vertex has to be halfway in between. Well, what's halfway between 0 and 6? Halfway between 0 and 6 is 3. I take the x number of 3 and I plug it in. That gives me 9 minus 18 plus 7. 9 minus 18 is negative 9. Negative 9 plus 7 is negative 2. So my vertex is the point 3, negative 2. Okay. I play a game of connect the dots with a nice smooth curve. And I'm good. Okay, you go ahead and try B, and I'm going to warn you something with B. You see this negative in front here? What that's going to do is it's going to make the parabola go that way. It's going to make it go upside down. But before you do B, I'm going to do problem C here. So you might want to watch. We'll go through it again. Alright, so if I'm doing problem C, first thing I'm going to do is build a table. I'm going to begin by finding my y-intercept. Again, I like finding y-intercepts. It's a nice, easy thing to do. I plug 0 in, I get 0 minus 0 plus 7, that's 7. So I have 0, 7. Once again, I know there has to be another spot somewhere. I don't know where. It could be over here, it could be over here, but I know there has to be another spot where y is 7, because that's the symmetry property of parabolas. So I come back to my equation, and I'm going to plug 7 in for my y number. 7 equals 2x squared minus 7x plus 7. Now you might have noticed something. This was kind of a happy coincidence that we got 7 both times, but notice that y-intercept isn't always 7. But notice that when we subtracted 7, those canceled out and gave us a 0. This time we got a 7. Our first step in solving is going to be subtract 7 on both sides, and we get a 0. And that's always going to happen. Always, always, always. The number you have here on the end is always going to be the same number that you put here. And what's beautiful about that is it guarantees that this thing always over here will always factor, because this thing's never going to have a number here, so you're always going to have a common factor of an x. So I take my x out. So that gives me x equals 0. That's always going to happen. That's always going to be one of them. This one, 2x minus 7 equals 0. I add the 7, and then I divide by the 2. I get 7 halves. Well, that's unfortunate, but that's life. Sometimes you get fractions. There's no way to avoid it. Let's see. 7 halves. 7 halves is 3.5. So I've got 3.5 and up to 7. So I mark that point right there. So I'll label these. This is 0, 7. This is 7 halves, 7. Okay, so well, this becomes kind of a pain in the neck now that we got a fraction here. Our vertex has got to be halfway in between. So halfway in between, I take 0 and I add 7 halves, and then I have to divide that by 2. So that's 7 halves divided by 2. I think of 2 as being a fraction, 2 over 1. I flip and multiply, I get 7 halves times 1 half, that's 7/4. So I know my x value on my vertex is going to be 7/4. Alright, well, fractions, you know, fractions, we live with them. Might not like them, but we live with them. To find the y value, I'm going to go ahead and use my calculator. So I'm going to take 2 times 7/4 squared. Notice I put that 7/4 in parentheses. Minus 7 times 7/4. Whenever you have fractions, good idea to plug them in parentheses. Plus 7. 0.875. Okay, that's a little bit smaller than 1. I guess I'd like my calculator to give me a fraction. 7/8. Okay, so where is 7/4? Well, 7/4 is 1 3/4. Or think of it this way, 7/4 is a little bit smaller than 8/4, so it's a little bit smaller than 2. And then 7/8 is a little bit smaller than 1. And unfortunately, this can happen. The vertex does not always come out to have real pretty numbers. Sometimes you get ugly little decimals like this, or ugly little fractions, and you live with them. Okay? Here's my parabola. Okay, so now you might want to go back and try B. With B, the numbers are going to come out nice. I promise you the numbers are going to come out nice. But once again, when this number is a negative, the thing that's going to happen is the parabola is going to be upside down. Your vertex is going to be a high point. So be expecting that. Alright, number 5. Kind of similar problems, except the directions are slightly different. The directions say find the x-intercepts and the y-intercept, find the vertex, and then graph. I'm going to do B. I'll leave A to you. I think A is a little bit easier, so I'll do B. I think B is a little bit harder. First off, it says find the x-intercepts and find the y-intercept. I'm going to start with the y-intercept because the y-intercept is always easy. To find the y-intercept, I plug 0 in for x. When I plug 0 in, I get 0 minus 0 plus 24. That's 24. So 0, you might notice I made my scaling pretty big here so I could make it fit. 0, comma 24. All right, to find the x-intercepts, I plug 0 in for my y number. And I'm going to get two answers here, I think, because I have 0 equals x squared minus 10x plus 24. Once again, we spent a lot of time in the previous few sections learning how to solve these. We know we should factor. I factor, I get x minus 4 and x minus 6. So I have x minus 4 equals 0. X minus 6 equals 0. I get two answers. X is 4, x is 6. I plot those 2 points. 4 and 6, comma 0. So 6, comma 0, 4, comma 0. I don't really need to label them since I have scaling on my axes, but I like to. All right. Then it says next, find the vertex. Alright, well here's the advantage of finding the x-intercepts. Before, we found the point 0, 24, and then we would find another point up here, and we would say the vertex is halfway in between, which is true, but at the same time, down here, I've got 2 points that have the same y value. Since I have 2 points with the same y value, it doesn't matter if they're down here or up there, the vertex still has to be halfway in between. Halfway between 4 and 6 is 5. So if you can find the x-intercepts, you can find the vertex by simply going halfway between your x-intercepts too. Alright, I come up here, I plug in 5. That's going to be 25 minus 50 plus 24. 24 and 25 makes 49. 49 minus 50 is negative 1. So my vertex is right here at 5, comma, negative 1. Connect the dots. There we go. Alright, so like I said, you give problem A a shot. Pretty much the same thing. I think slightly easier to solve in finding your x-intercepts. Okay. Next, we have a little bit of a word problem here. It says, a batter hits a baseball. The ball's height in feet, h of t, after t seconds is given by this equation. Height is negative 16t squared plus 140t plus 3. What is the ball's height when the batter makes contact with it? That's a very fancy way of saying I want you to build a table. Of course, t is our x and h is our y. What is the ball's height when the batter makes contact with it? Well, when the batter makes contact with it, that's when we start. That's right at time 0. So this is a fancy way of me saying find the intercept. I plug in 0, I get 0 plus 3. That's 3. Okay, then it says, what is the maximum height of the ball? When does it reach this height? Well, look at what we have for an equation. We have a quadratic equation. It's got a t squared, and this has a minus in front. And what I told you a little while ago is when you have a square and you have a minus in front, the parabola, when I go to graph it, is going to be this way. It's going to open downward. So when it's saying what is the maximum height, the maximum is going to be up here somewhere. That's going to be at the vertex. So when you're dealing with parabolas and you're ever asked what's the maximum or what's the minimum, that's a fancy way of saying find the vertex. So to find the vertex, I'm kind of halfway there. I found the y-intercept, well in this case the h-intercept. What I would do is I would now plug 3 in for my h number. When I plug 3 in for my h number, I have minus 16t squared plus 140t plus 3 equals 3. I'm going to start drawing my graph here. 0, 3 is right about there, I guess. Oh, you can't see what I just did. I probably shouldn't be jumping around, but I did. There's 0, 3. Okay, let's go back up and solve this equation. Subtract the 3 on both sides. Minus 16t squared plus 140t equals 0. I can factor the t out. I could factor a number out too, I suppose, but I'm not going to. I'm going to be a little bit lazy here. I'm just going to take the t out. Minus 16t plus 140 equals 0. This one gives me t equals 0, but I already knew that. This one gives me negative 16t plus 140 equals 0. So negative 16t is negative 140. Divide, t is, I'm going to take my calculator, negative 140 divided by negative 16. My calculator gives me 8.75. I guess that's okay. I guess I'll leave it as a decimal since I don't have to round it off. If that was a decimal that went on forever, if it was like 8.77777 going on forever, I wouldn't round it off. I would leave it as a fraction. Maybe we'll convert it to a fraction. That also happens to be 35 over 4. Alright, but coming back to my graph, I now have this other point, 8.75. That's just a little short of 9, comma 3. 8.75, comma 3. Alright, well, we do the same old trick. Where's the vertex? The vertex is halfway in between. Halfway between 0 and 8.75 is 8.75 divided by 2. So I'm going to continue my table here a little bit. My time is going to be 8.75 divided by 2. I'm going to take my calculator. My calculator tells me that's 4.375. So I've answered the second part. When does it reach that maximum? It reaches it at time 4.375. What's the height? I take 4.375 and I plug it in. Negative 16 times 4.375 squared plus 140 times 4.375 plus 3 is 309.25. So, what's its maximum height? 309.25. When does it get there? 4.375 seconds. So to finish my graph, I mark my vertex 4.375, just a little bit more than 4. 309, a little bit more than 300, right about there. So I'm going to mark my vertex 4.375, comma 309.25. To finish off my graph, I would start here. Graph comes up, goes back down, and I would stop right there. And we've talked about this sort of thing before. I wouldn't go to the left and keep going and draw an arrow because time can't be negative in this problem. I started at time 0 when I threw the ball. By the same token, the ball in theory hits the ground, so it doesn't come down any lower. Again, if you had drawn this and drawn lines and arrows like that, I wouldn't mark it wrong, but we really shouldn't. We really should stop right here and we should stop right there. Alright, the last problem. This is one for you. I'm going to give you a picture. Here's the picture. And I'm going to ask you some questions. And the questions are, where's the vertex? So you should be able to look at that graph and tell me where the vertex is. You should be able to look at that graph and give me the x-intercepts. You should be able to look at that graph, give me the y-intercept. What is y when x is 6? So you're going to come over to x equals 6 and find the y number. What is x when y is 3? And I'll give you a hint, there's more than one correct answer there. And then, does this function have a maximum or a minimum, and what is that value? Again, when I'm asking you maximum or minimum, when we're dealing with a parabola, I'm simply saying, find the vertex for me. Okay, as always, when you have questions, drop me a note or come by my office.